So the beginner level course of Red Hat is RHCSA, Red Hat Certified System Administrator, right? So it
Okay.
is composed of, you can say, two books or you can say two courses. So the first one is RH124. In general, we call it as Red Hat System Administration 1. And the second course or second book is RH134. These are the course codes. So together we call it as RHCSA. If you read these two books and you know how to perform the topics in these books, so you can say that I have studied RHCSA. For some peoples like you or somebody who has some basic knowledge, they have created a separate track that is RH199, that is rapid fast track course for RHCSA. And this is consist of only one single book. So I'll show you all the three books, starting with this. This is RH124. So you can see RH124, and if we see the table of contents, you'll see all the basics, like starting from what is Linux to how to access the command line, how to manage files from the command line, okay, how to get helps, how to edit files, how to manage users and groups, right? How to control access to the files. This is an official Red Hat student guide, right? So it will be better if we follow the same. So then monitoring and managing Linux processes, controlling services and daemons, configuring and securing SSH. So you might be aware of this, right? Because generally
Yeah.
you log into your DBA through PuTTY or any other SSH client, right? So you are aware of this. That's it. And then how we are storing logs and analyzing logs on the machine. What is happening on the machine? How to manage
Oh,
networking, the basics of networking, archiving and transferring files and all. Then we'll move to the second part, that is 134. So if you see 134, we'll have some advanced topics in it, like how to write shell scripts, right? How to schedule tasks, how to tune our system performance, how to control access to the files with the help of ACLs, access control lists, right? Then how
okay.
to manage its security, the storage. From these four chapters are totally dedicated to storage, and this is one of the most important topics with respect to the exam. If you decide to go for the exam and to go for the certification, so storage is one of the important topic, very important
Okay.
topic. Then how to control the boot process, how to repair things if something goes wrong, how to manage the firewall, how to install Red Hat with in a different manner. The simple installation is very simple like Windows. Here we are talking about some different types of installations available. Then containers. Are you aware of this thing, containers? This word container, have you heard? Nowadays, like some words are very famous in the industry. Whether you belong to that industry or not, you might have heard somewhere, like Docker, DevOps. You might have heard these words. So the basic building block of this Docker or Kubernetes is containers. So you'll get some
Okay.
introduction to containers, how you can deploy applications easily.
Okay.
So these are the two courses we will cover during this course. And this is RH199, that is the combined version of these two modules or books or courses. So in the combined version, you will find all the topics in short, right? So if you compare, here you will get 658 pages, here you will get 478, somewhere close to 1000, and here it is 660 only. So it is a slightly shorter version of these two books. So if you study this course and then you will go for the exam, so you have to perform a practical exam, and the exam name is EX200, right?
Okay.
It is a practical exam of 3 hours in
Okay.
which you have to score 210 out of 300. It's a exam with no pen and paper and no multiple choice questions. They
Okay.
will give you around 20 to 22 scenarios, and you have to read the scenario and then perform the same on the machines.
Okay.
Fine. So if
Okay.
you clear this exam, you'll become RHCSA. Fine. That's
Okay.
all about Red Hat. Let's start a topic. So let's start with chapter 1, right?
Okay.
Fine. I hope all the things are clear so far. The content of
Good.
199 is the common content of 124 and 134. Let's see.
Oh, okay. 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 Okay.
That's why I didn't show you. You can see
Oh,
access
okay.
system and get support, manage files from the command line, right? Managing local users and groups. Yeah,
Okay.
same. Either we can complete these two books, 124 and 134, or we can go with 199. That is
So
our choice. I suggest you to go with these two books. It
okay.
will be
Okay.
lengthy, but we'll get more knowledge, right?
Okay. Okay. Sounds good. Sounds good. Sounds good to me.
Yeah. So let's
Mm.
start with, let me tell you the story, then you will understand on your own.
Okay.
In chapter 1, we will understand what we are going to learn throughout the course.
Okay.
So let's begin. So, RHCSA is the name of the course,
Okay.
right? And
Yeah.
these are the contents of 1 to 4 in more shorter form.
Okay.
The chapter 1 says getting started with Red Hat Enterprise Linux. So what we are going to study is Red Hat Enterprise Linux, right? So what
Yes.
is this Red Hat Enterprise Linux?
Okay.
It is a server-side operating system, correct? So can you quickly tell me what is an operating system? So operating system is something which controls the hardware, right? To control any hardware, we need a software, and that software name is operating system. So here, what is the name of the software? Name of the
Right.
software is Red Hat Enterprise Linux, right?
Yeah.
And now operating system is okay. What is this server side? Can you give some examples? Any other example apart from this? Yeah, apart from this particular name, Red Hat Enterprise Linux. Apart from this, any other operating system we use to install on servers? Yeah, Windows, which OS? Windows is the name of the product, right? One product, broad category.
Right.
It
Right.
is
Yeah.
Windows Server, any version, to Server 2008, 12, 16, 19, 21, 22, right? So these are the operating systems we generally don't see in our home, right?
Right.
These are the operating systems we generally use to install on servers, that is in data centers. For personal computing, which operating system we use? Windows. Windows 7, Windows 8, Windows 10, and Windows 11 is now the latest one, right?
Yes.
So what we are going to learn is we are going to run and manage a operating system which will run on server side, that is on server. So what is the difference between server and this personal computing, or you can say client systems? I'm just trying to get uh, what is you can say what is your status technically by
Oh,
asking
okay.
these
Okay.
small
Okay. Okay.
questions. But technically, what is the major difference is technically. If I'm working on Windows 11, I can make it run a DBS database server on it. Is it possible, right? I'm saying, can I install a database Oracle DBA on Windows 11? Anyhow, with the help of emulator, or we can say I can install SQL Server on it, Windows. Is there any issue if I use Windows 10 or 11 instead of Windows Server? Will it make any difference? But it will not make any difference. So
Okay.
what I'm trying to tell you is, what is server? Server is also a software, right? It is nothing physical, right? Everything is code. We are saying operating system, it is code. We are saying utility, it is a code. We are saying drivers, it is a code, right? Everything is a piece
Okay.
of code. So server is also a program which runs on a machine, and the main difference between a client and server is server respond to client's request. Got my
Oh,
point?
oh, okay. Got you. Uh-huh.
Yeah. The main difference between a client and server is that we don't use server. Our users use the server. Correct?
Okay.
You are installing a database, you are creating a database on the machine for your clients, not for yourself, right? So that is the difference between server and client. So Windows 7, 8, 9, 10, 11, these are all used for personal computing. When it comes to server, we install specialized softwares which can run an application which is used by thousands of clients, thousands of users simultaneously, right? So that is what we are going to learn. Red Hat Enterprise Linux, a operating system which is going to be installed on a hardware which is going to run an application which will be used by lakhs of users, right?
Right.
So that's why we use enterprise level softwares for running our application, that is server, right? So we are going to learn Red Hat Enterprise Linux. Now, what is Linux? Let's continue with what is operating system, right? So here I have a small diagram to explain what is operating system and how operating system works. So you can see at the core of this diagram, you will see hardware, right? So as we discussed, operating system is something which controls the hardware. So the very first software we are going to use on a hardware is operating system. Okay, so operating system is one software. This circle is OS. So operating system is a big software, right? So we can say it is not one single software. It is a collection of softwares, modules, and they are working together to achieve what operating system does, right? Like controlling of the hardware and performing various tasks. So we have different softwares available in the operating system, like device interfaces to interact with the devices, file system, multitasking, hyper-threading, right? Your storage management, CPU management, memory management. For each and every activity, we have a specific software available in operating system, right? So you can say collectively they are working together. All the modules, all the softwares available in the operating system, they are working together like an organization. Like in your organization, you are working as a manager or team lead or team member, and you have an hierarchy, right? And at the top of the hierarchy, you are having a boss or CEO or MD, right?
Right.
So who takes all the decisions? You are the one to follow, and the boss takes the decision, right?
Right.
So operating system also works like an organization where we have so many employees. I have named them, right? CPU management, memory management, disk management, process management, file system management, multitasking, hyper-threading, security, and all are controlled by this boss. Name of this boss is, can you read it? Yeah. So the boss in the operating system is known as kernel.
Oh, okay.
Okay, kernel is the one who controls each and every component of the operating system. And you can say, if we compare operating system to our body, so kernel is the brain of the body,
Okay.
not the heart. Sometimes people say it's heart, right? So it's not heart, it's brain, the
Okay.
controlling one, the one who controls everything. So our brain controls everything, right? So each and every operating system, it is a general diagram, right? You cannot say it's for Linux only or Mac or Windows. It's a general diagram. It is true for each and every operating system, right? You name any AIX or Mac or Windows or Linux, Unix. So every operating system has this schema, one boss known as kernel, and each and every software is controlled by this kernel. And in Windows, we have the name of the kernel is anti-kernel. You have seen this term on internet many times, Windows, anti. So it is the name of the kernel used in Windows. And can you guess what is the name of the kernel used in Linux? Name of the kernel in Linux is Linux. The first lesson of the day is Linux is not an operating system.
Okay.
Linux is a kernel and it is a part of the operating system. So one of the part of the operating system is Linux. So why we say Linux operating system? Because let's go to the history. So what is Linux? Linux is a family of open source, Unix like. One more myth is people say that Unix and Linux are same, or they are, Linux is the updated version of Unix, right? But it is Unix like because Unix is also mostly used command line and Linux is also mostly used command line.
Okay.
So that's why I'm using this term here. Otherwise, Linux has no relation to Unix. So Linux is a family of open source Unix like operating system based on the Linux kernel. So Linux is a kernel and it was developed by Linus Torvalds in 1991.
Okay.
So that's why you will see that you will not find any Linux based operating system before 91.
Okay.
And Unix was there in 1977, 78. It was developed in AT&T Bell Labs, right? So, and Unix is a proprietary software. You cannot use it for free. You have to purchase it for use, right?
Okay.
And Linux is free. So you can see Unix has nothing to do with Linux, right?
Right.
Now, each and every operating system needs a kernel, as I told you earlier.
Yes.
So if you want to develop an operating system, right?
Right.
So what is the, let's say, Daniel OS, right? So you will start developing, right? Then what is the most important part you need in your operating system to develop Daniel OS? So if you use this already available kernel developed by Linus Torvalds, then half of the work is done in no time. You want a kernel and you have a kernel readily available with you, that is Linux. So half of your work is done in no time. If you want to develop operating system, you need kernel and you have a kernel already available, that is Linux. So you can use it if Linus Torvalds allows you, right? So what Linus Torvalds did in 1991, he made this software freely available to everyone in the world.
Okay.
So from there, the journey started with open source operating systems. And
Okay.
all the operating systems which use Linux as the kernel, then they are known as Linux operating systems.
Okay.
That's why we use Linux word, because we have more than 50 operating systems available, and all are based on Linux. See, Elma Linux, ALT Linux, NTX. Even you can develop your own operating system with this kernel because it is free to use. Anybody can use it, learn it. You can see all are Linux because they are using Linux kernel. And how
Okay.
they are different? Because they are having the code of this kernel, so they can modify it according to their need, according to their operating system, according to their functionality, working, whatever design, whatsoever thing you will take. That is because of the idea of what? Open source. So can you tell me what is open source? Any idea? Yeah. So open source is an idea, an initiative to make people learn computers, softwares freely and easily, right? Open
Okay.
source is an idea to support the community, right? So how to support the community? If you have designed a software, let's say you have created a software to create edit images, but you want to sell it. So then only those people can use that software who can buy, right? Apart from those persons, nobody can learn editing of images from your software, right? So open source is an idea to support the community, that anybody can learn computers, softwares, how to use it, how to run it, and how to code it. So it is an idea started in 1982. Fine. We started
Okay.
in 1982 with an open source foundation, an NGO or an organization which has been, which had this idea of supporting the community through this learning. So any software whose source code is freely available for the community and anybody can use it, anybody can study it, anybody can modify it and share it, then we call it as an open source software. Fine.
Okay.
So can you name any open source software? Have you used any open source software? Yeah. But in general, it's more of a technical, right? For common man just
Oh,
using computers. Yeah, Android. It is getting used in 75% of the phones are Android, right? On this
yes.
planet, right?
Yes.
Why? Because of this idea, open source. Else, most of the people cannot afford a smartphone because then they will have to pay for the OS also, right?
Yes.
So, because of a free mobile platform operating system, the cost of smartphones are very less and anybody can afford it, right? So, this is the
Right.
idea of open source. Now, what are the benefits of the open source? So, we have all the benefits, you can say, you name it and it is there with the open source, right? You can control it, training, security, stability, right? So security is a little bit confusing because why? Can you add some points to it? Why with the open source software security is not good enough? But if you are using an open source database in your organization, so what do you think? You are safe? Your database is safe? Your data is safe? Yeah, because if you can inspect the code, the bad people also,
Okay.
right? So
Yeah.
using an open source software, you have to be an like more technical, more updated, and more aware of the threats available with the software, right?
Okay. Okay.
So technically, it will not improve the security, but yes, if you are a step ahead of the attackers, yes, you can, right?
Right.
You have to always stay ahead of the attackers. So now, if something is available for free, let's say now you have developed Daniel OS, right?
Okay.
And as you have gained everything from the community, you have also made it available free for the society, right?
Okay.
So do you face any challenge or is you'll get name and fame, right? Apart from this, anything else you'll get any issues, troubles, or only name or fame? Yeah, but I'm talking about any challenge you will face, any challenge through legal issues and all. Let me tell you. Let's suppose you have created this OS and now
Okay.
you shared it with your friend, right?
Okay.
Let's say Sam. You said, Sam, this is an operating system I have created. Use it and tell me how is it, right?
Okay.
Now Sam tried to install it on his laptop and just after installation his hard disk got crashed. So there are very fair chances Sam will blame your operating system, right?
Right.
So now you have done something good for the society and you are not expecting anything from the society, but society is blaming you, right?
Okay.
Maybe some unknown person, that person might sue you in the court
Okay.
for destroying the hardware or loss of data. So from there, we came up with the idea of open source licenses, right? And here we can write the terms and conditions to accept. License doesn't mean here you have to pay. You have to agree to some terms and conditions
Okay.
to save this idea. So here we have several versions of license and it is generally known as GPL, General Public License.
Okay.
So we have different versions of GPL available. Let me give you one or two examples how we can change different versions. So let's suppose there is one software and I'm using that software. I'm modifying that software. And now I have came up with this new version of that software which is having more functionalities than the previous one, right?
Okay.
But if you are using an open source software, then you cannot keep that software as your proprietary software. If you have developed something out of an open source software, then it will become open source automatically.
Okay.
And that is the idea. The first version, you can say copyleft license, which means whenever you will edit an open source software and create something new, that new will be automatically an open source software.
Okay.
Nobody needs your permission to make it open source, right?
Okay.
So now the second thought comes to the mind that you have worked on an open source software and you have spent like your 6 months on it, your energy, your money, your time, right? And in the end, you are getting nothing. So will you think out of 100 people, how many people will work on open source softwares? Rarely
Listen.
one or two, right? Because you are getting nothing out of it. Everything is going to be public. So then GPL came up with an idea of permissive license, where you can allow this thing that you can earn or you can modify and you can sell it, but you have to stick to some terms and conditions. And here you can take the example of Android. Android is developed by Google, and all the mobile companies are selling Android, but Google is not charging anyone that you have to pay some royalty or this that through any way, right? Because it is an open source software. But Google allowed everyone that you can sell it, but you have to stick to some terms and conditions, right?
Okay.
And one of the condition is, without a Google account you cannot use Android. Fine. So now it is win-win situation for both. All the mobile companies, they are getting a wonderful operating system for free, and Google, they are getting all the wonderful data throughout the world, right?
Right.
And Google is earning from that data, right?
Yes.
So this is an idea of open source license when we have different versions available, but we'll not go to the legal side of this, right? Because we are going to work on technical side. So next, what is Fedora? Have you heard this term Fedora? It's an example, not actually you can say. I'm not about aware of the legal aspects of Android. I've just given you an example. What is a permissive license?
Oh, okay,
Permissive
okay.
license is something where you put some terms and conditions and allow the world to earn out of it, to use
Oh,
it
okay.
in their own way. Let me change the example. Let's suppose you developed a software to control drones,
Okay.
and those drones are highly specialized that they can like hide themselves in the air.
Okay.
But if you release it in the open source, then it will be dangerous. Anybody can use it. The bad people can use it. So
Right. Right.
you will create a GPL and you will mention that this is for use only for the defense, the
Okay. Okay.
government on the government. So this is permissive license where you mention some terms and conditions.
Okay.
Then only you can control. No, otherwise, no terrorist can use the same software to control their drones.
Okay.
Fine. So permissive license means you modify the terms and conditions so that the code reusability should not stop. People should
Okay.
not stop working on the open source software. As I told you, in this condition, copyleft license, you worked on the software for 6 months and you are getting nothing. So you will not
Okay.
work, right?
Right.
Then the idea of open source will die then and there. Nobody will design open source softwares. So to keep this idea, to keep this flame glowing, we need some permissive licenses where
Okay.
the code reusability, the working of people on open source softwares will keep moving. So now, because of this idea, you will see that many open source softwares are ahead of paid softwares. Means I'm saying if you want to create an like video, you want to do
Right.
video editing, so you buy paid softwares, right? But there are many open source softwares available in the market, right? Which
Yes.
are giving uh, competition to paid softwares. So because of this idea of open source, because of this idea, many people are working on the code. So the code is improving day by day. Next, what is Fedora? So why you have not heard of Fedora? Because Fedora is the testing bed for the development of CentOS and Red Hat. So it is the testing bed and it is working in the background. So that's why it is not used much. Only those person use Fedora who are developing something on this Red Hat or CentOS. So
Okay.
all the development part or the development work is done on Fedora. So it is the
Okay.
testing bed, and it is an open source project funded by Red Hat only. So it is a company and project run by Red Hat, and it is a testing bed for the development of CentOS and Red Hat. And you can say Red Hat and CentOS both are enterprise level softwares, enterprise level operating systems, which you can use for the business, right? You can say Red Hat is also an open source software, right? Red Hat Enterprise Linux, RHEL is also an open source software, right?
Yes.
CentOS is also free, correct? So
Uh,
from
uh,
where I am saying Red Hat is open source, right? So it is free to use, right? CentOS is also free to use, developed by Red Hat only. So what do you think from where Red Hat is earning? What is the source of income for Red Hat? If everything is free, support. So they don't sell the software, they don't sell the operating system, they sell the support. That is how they earn, right?
right.
And Red Hat is something which you can get support from Red Hat, but in CentOS it is a community edition and you will not get any support on this. It is free to use, updates are also free, and there is no support because it is completely open source, free to use for enterprise, right?
Okay.
So this is a small diagram explaining the development cycle for this Red Hat and CentOS, right?
Okay.
So now, so far what we have covered, we know what is a kernel. Kernel is the core of the computer operating system, and it has complete control over the operating system. Now,
Okay.
let's come to this diagram and let's see how a computer works, right? So, hardware, on the hardware we install OS. On the OS we install applications, right?
Yes.
So these applications. In Windows, we install MS Word, MS Office, Google Chrome, Edge, right? Photoshop, Adobe Reader. So all these circles are applications. So these names are not so common because they are all Linux-based applications, command line applications.
Okay.
But you can compare it with all the names I have taken on Windows Live, MS Office, right?
Right.
So these are all the applications. Now to interact with the operating system, an application needs an shell.
Right.
So what is a shell? Shell is an interpreter. What is a shell? Shell
Interpreter.
acts as an interpreter to communicate between the application and the kernel.
Okay. Okay.
So in the operating system, only the kernel is there to for the communication. You cannot directly interact with the hardware, right?
Right.
So what is a shell? Shell is an interpreter between the application and the kernel. And why this interpreter is required? Because kernel deals with the low level code, that is machine level code, right? Because it is controlling all the hardware.
Okay.
And application is the high level code, right? Like your HTML, your .NET, all the application, all these languages are high level languages, right? So they cannot interact with the hardware. So kernel is something which understands low level code, machine level code, and application work on high level code. So interpreter is required to convert, right? High level to low level, and then when kernel perform all the operations and send output back to the shell, it will convert it into the human readable language, right? Understood this flow, how an operating system works? Application interacts with the kernel, and this interaction is done with the help of an interpreter called shell.
Okay.
Fine. And then
Yeah.
kernel interacts with your hardware, your CPU, your memory and devices, and perform the action, whatever action is requested from the application, right? And that shell is something which works as an interpreter here, and the shell name is bash,
Right.
right? So by
Yeah.
default, we use this shell bash. The older version of bash is sh, just shell sh. Initially, this shell was there, sh. Then it's Steve Bond developed another shell out of sh, and it named as born again shell bash. And we have various other shells, ksh, tcsh, zsh, right?
Right.
And each is having different like functionality to act as an interpreter on what type of operating system, what kind of work you are performing, right?
Right.
So the last thing is terminal. Terminal is something where you types the command, right?
Right.
So there are so many softwares available like Genome Terminal, Console, Xterm, right? Mobile Xterm, Putty, Eatem, all the applications where you can type your command, they are known as terminal. So now we have understood the flow of communication, right? Application sends signal to the shell, shell interacts with the kernel, kernel perform the operation with the help of hardware and all the softwares, and then this back channel flow is there, right?
Right.
So everything is done by whom? Us, right? The users.
Right.
Whatever I have told you, it is done, started, initiated by us, that is users. And users are also of two types. One is privileged super user or privileged user, which is having powers, and unprivileged user or regular user, which are not having powers. So in Windows, we have a name, a default name for this privileged user, and it is known as administrator. In Windows, we have a default user by default created during installation by the name administrator, right?
Okay.
And it is the super user. If you are having administrator password, you can do anything on the operating system.
Okay.
Similarly, in Linux, we have which user? You can name it.
Root.
Yes. So here we have the same functionality, same powers, but the name is root. So that's all from the introduction part, and we have covered chapter 1 also. Let's start with this book 1. Okay. So far
Okay.
what we have learned, what is Linux, right?
Yeah.
Now in chapter 2, we will learn how to use the command line, how to type the command, how to see the output, right?
Right.
In chapter 3, we will learn how to manage files. Like in Windows, we use my computer, we go to the D drive, C drive, E drive, and then we go to the folders, we create folder, we copy file, copy paste, cut paste, delete, right? All the
All right.
operations we will learn through command line in this chapter. In chapter 4, we will learn how to get help. If I am not aware of something, how to get help from this operating system to learn things on your own, right? So how to get
Right.
help we will learn. Then how to edit files. Like if you want to edit a text file, you use Notepad, right? In Windows. Here we will learn an editor known as VI, Nano,
Right. Yeah.
right? So in chapter 5 we will learn how to edit files. In chapter 6 we will learn how to add a user, how to create a group, how to add a user to a group, right? User and group management we will learn. Chapter 7, we will control access to the files. which permission, which file can be accessed by which user, right? Read permission, write permission, execute permission. We can control the permissions, right? On the
Right.
files. Then
Right. Right.
monitoring, you were saying load, है ना? Processes, right?
Right.
So in this chapter, we will learn how much CPU is getting used, how much RAM is getting used, right? Which processes are running in our system? What is the load of the server? Do you have to take any action to control the load? And how to take the action? Everything we will learn in this chapter,
Okay.
right? Then we will learn how to control the daemons and services. Like if you install Oracle DBA, you will have to restart it, right?
Right.
Sometimes that is how to control start, stop, right? Restart, enable, disable, how to do it. Then how to
Right.
take SSH, that you already know. Then how to read logs, where logs are stored, how to analyze if something happens to our system, right?
Okay.
With the help of logs. Networking, it is the basic part, not that high level. So if you are having a Linux machine and you want this machine to become a part of a network, a node in the network, so you can do it with this knowledge, right? You can configure the IP address in the machine,
Okay.
right? Then basic operations like if you want to take a backup of something, you have to create an archive, right? So how to create archives? Then if you are creating a backup, you need to transfer it on the backup server, right?
Right.
So archiving and transferring files, how to do it? Installing packages, how to install softwares on this platform, Linux. Like in Windows, we have executable files on our system. We get exe files from whatever source, and then we'll do a double click, right?
Right.
And then the software is installed. Here we learn how to install a software on command line, right?
Okay.
Then we'll learn about file system, how we can access disk partitions. Like in Windows, we have C drive, D drive, E drive. What is this drive? They are all partitions, right?
Okay.
So here also we have partitions, similar, but the method of accessing the file system is different. Then we'll learn about how to analyze the server and get support. If something is happening, you don't feel that our server is in good condition, right?
Okay.
So, and you know how to repair it. So you need support, right?
Yes.
Then how will you get support? We will learn in this chapter. How to contact the Red Hat support team, what material they need, how to create that material or report, and then you will send that report to Red Hat team, then they will analyze your reports and give you the solution, right?
Yeah.
That was book one. And I think I have explained this content to you, that book
Yeah.
two, right?
Yeah. Yes.
That, yeah. So anything else you want to know?